and welcome to the launch of Aivia 10. This is a really special one for me. I'm Luciano Lucas, the director for Leica Aivia. It's really a pleasure to be here and introduce to you this new iteration of our software. We've been developing very quickly as usual. If you remember, we have typically 2-3 releases per year. You can see them all listed down at the bottom. And some of the releases are heavier on machine learning and deep learning. You can see here in red the main functions or features that heavily leverage deep learning and machine learning, and the ones in gray are the ones using standard technology. Aivia nowadays includes functionality for 3D object analysis, 3D tracking, neuron analysis, rendering of very large datasets, segmentation of electron microscopy datasets. We also have a very advanced and GPU accelerated pixel classifier that works great for most segmentation tasks. And more recently, we've introduced a number of pre-trained deep learning models for image denoising as well as super resolution. They're all in our model zoo, in our model library on our website. I think I have a link for it later on today, but if not, you can just go to our website and find it, search for it for model zoo and or model library, and you'll find it there. So we've been extremely busy as usual, and this time around we're focused on these new features that are listed down here with the Aivia 10 series that we start today. We expect to have at least one more release this year. We already had one in January. This is the second one, and we expect to have another one later down this year already in the 10 series. So what are the key features for Aivia 10? We have 4 categories. The first one is related to our entrance into the Leica Microsystems family. We're now, as you know, part of Leica Microsystems since March 16th, over 4 months now. And we have a new library viewer as well as additional support for some files and rendering for tau-sense data. We're also introducing the active tiles, which control the GUI and also trigger Aivia.learns. We're introducing Aivia.learns itself. This is a system to predict the parameters for image segmentation. And we've done some work on our memory management as well as the Aivia.tiff file format itself to try and make the conversion faster and the files smaller. And we provide actually quite a lot of documentation now so that you can learn more about the Aivia.tiff file format. And if you want, you can even create your own Aivia.tiffs in your own applications. So let's focus a little bit on the readers and the rendering modes. First of all, I wanted to show here what the library view looks like. So opening a Thunder image dataset, it includes actually several images. I think there's 5 or 6, maybe 7 images. They all show, as you can see there under the Thunder image, I had some previously open images as well, or folders. And so I can see all the ones that I had previously open visible in thumbnails. I can then navigate either through the thumbnails or through the list. The metadata is always available as you move your mouse over the thumbnails. It shows you a little bit of the metadata, so you can easily know if it's a 2D, 3D, 2D plus time, or 3D plus time image. You select it, and then you can open it in Aivia directly. It will immediately open all channels and do a 3D reconstruction if it's a 3D image. Yeah, couldn't be much easier than this. We have added support for additional file formats. You can see here we used to have support for LIF. We've expanded the types of LIFs that we support, and we've added support for several other Leica files that you can see here. So now the coverage is quite complete. And of course, we'll continue to work on any missing formats. As you may be familiar with tau-sense, but if you're not, I can give you a brief summary. This is part or an option of Leica's confocal systems, the Solaris platform. And with this tau-sense system, if you are imaging two fluorophores that have a similar emission histogram, let's say GFP, they're both GFP excite and emit in the GFP range, that becomes really hard if you have a single detector and you cannot really see the two of them separately. So this would be the raw image, but with Tau Sense technology, you can additionally detect the lifetime fluorescence information for each of the two fluorophores, even if their emission spectrum is similar. And that's what you see here in 3D rendering mode over here, already with tau contrast on, and in 2D rendering with the tau contrast on, and you can start to see the difference between the mitochondria and the actin labeled images. And then going one step further with tau separation, you can actually create two channels that leverage this tau contrast, and now you have two completely separate channels. So what does that look like in Aivia? Here it is. So this is the original intensity only data, now with the tau contrast. That's what you see. And then the two channels separately. So this is in 2D. I think I will now flip to the 3D view in a moment. Here it is in 3D. So these are the two channels already separated with tau separation. If I go back a couple of steps, so this is the intensity only, and this is the tau contrast image. Yeah, so this now works really well in Aivia, and you can use all of the other tools that Aivia can offer downstream. If you're interested in learning more about tau sense, tau contrast, tau separation, just go to this application note. Was published in Nature Methods, I believe, and you can read all about it. There's a good description there of all the functionality offered with Tau Sense. So let's go forward and talk a little bit about the active tiles. So talking with many of you, what we understand is you have less and less time. That's the reality. Time pressures for administration, teaching, and so on make it hard to learn new tools and new technologies. And often image processing software can be pretty complex and sometimes hard to use. Moreover, because images are not all homogeneous, they're actually pretty heterogeneous, it can be hard to automate processes and to create results in a reproducible fashion. Moreover, we know you and most people prefer to focus on creative tasks rather than repetitive, time-consuming ones. So with all of these problems in mind, problems that you've shared with us, we went away and tried to think of solutions. And the active tiles is part of that solution, and the Aivia that learns is also part of that solution. And I'll talk a little bit about both of them in the next few minutes. Even though software today is highly capable, it still looks a little bit like this. So it has a cockpit type approach. Lots of buttons, a little bit like on a cockpit of a plane. There's lots of buttons, lots of knobs, and you can get everything done, but it can be really, really difficult to learn how to use all of this. Same in a cockpit of a plane or in the cockpit of a piece of software like what you see down here. There are, however, better approaches for this kind of problem. And one approach is to abstract some of the complexity, try to predict what the user may want to do, and present only the tools that are actually needed at each moment, and adjust that depending on the context, depending on what the user may want to do. That's what we try to do here. With the active tiles, we ask a question, what do you want to do? You can still search for things that you want to do in the search bar, but we provide you with 4 tiles that we think are going to help you get started in the fastest possible way. So the tiles help you get to a setup that is ideal for visualization, for exploration of results, to do 3D object analysis, or to teach Aivia. This triggers the pixel classifier, so you can teach Aivia how to detect objects. So this is the evolution that we are trying to do here. Go from a cockpit type of approach to a much more simplified and streamlined way to get into the software. Of course, you still retain all of the controls in advanced views. If you want to adjust anything, you can, of course. So we try to boil it down to one question. What do you want to do? And based on what you want to do, then we present you with the functionality that is needed to achieve just what you want to do. So this is what it looks like in Aivia. I have a data set already loaded. There's volume and volume rendering there. I'm going to select the visualize. I think I'm going to select visualize data, but that's the 4 tiles. You can see there, visualize, explore, results, and so on. So this is the visualize data. It brings back or brings the controls up that are needed for volume rendering control, as well as the surface rendering control. In this case, I've already done some analysis. You can see there the liver, the whole mouse embryo, as well as the eyes and the brain. So these are the controls. You can also control the clipping planes or the ortho planes at the bottom, and some additional parameters like volume rendering quality are all available in that view. Then I change to explore results. And in explore results, it brings you an interface that has a spreadsheet, it has a chart, and it gives you a lot of space for the image in the center. It still gives you control over the volume rendering at the top, but it's focused heavily on exploration of results. So in this mode, if you're already familiar with Aivia, this is no surprise, but in this mode, you can, the 3 parts, so the 3D rendering, the chart, as well as the spreadsheet are connected. And so anything that you select in one of the 3 views is selected on all the other ones. Then the teach Aivia sets up Aivia for learning how to do object segmentation. And it goes to the pixel classifier. It hides away all the other controls, all the other tools, and it highlights the pixel classifier, and you still keep the volume rendering. Then you use the painting tools to determine what you want, and then also the background, and just paint away. So you're teaching Aivia what the embryo is in this case. As you can see, it's very, very straightforward, and you get previews straight away. And then the final one that we have a tile for is the 3D object analysis, which I'll mention in a moment. So with these 4 tiles plus the search bar that we had introduced before, but we've enhanced it even further so that it has more commands and it has access also to our YouTube videos. We make Aivia a lot easier to learn, a lot easier to teach. It should be much faster for you to get the results, and a lot easier for you to find what you're looking for. In other words, you have Aivia, your way. The next topic I'd like to cover is Aivia that learns. As the name indicates, what we're trying to do here is get to an evolution of Aivia that actually learns as time passes and it gets better. And we want to do that in a kind of semi-passive way. We're not talking about training a deep learning model to do segmentation or training a deep learning model to do image restoration. It's a little bit more high level than that. So what we're thinking about is, given any image, so this is an image of an embryo, the user will spend some time using the current interface to set up these sliders, these parameters, the ones you're familiar with. Intensities, object size, smoothing factors, whether or not you want to split objects that are touching, and so on. These parameters down here are going to be captured, and they're going to be part of what we're calling the metadata. We also collect some telemetry, and in some specific cases, we can collect also image data. I'll talk a little bit more about that in a moment. So we collected this data from users. We then train an AI model to learn the association between the raw data and these results. And then we deploy that in such a way that everybody can use it. Essentially, we want to go to a situation where the user doesn't have to learn all of this up front. In principle, it will be possible to select what he or she wants to do, and from there, get at least a preview that looks reasonable and can be easily adjusted. So for now, we are focusing on the 3D object analysis recipe. That's why we have added that to the active tiles. That's the one. So if you click on this, it will activate this pre-trained deep learning model. Before I go further, I wanted to mention that this is an opt-in. When I talk about capturing or gathering user information, this is opt-in only currently, and we don't plan to change that. So you can turn it on when you're installing the software right at the beginning. So help improve Aivia by allowing collecting of usage data. So that's one way you can turn it on. If you don't turn it on when you install it, you can then turn it on later under the options, advanced consent telemetry, turn it on there. And if you want to find out more about what we are actually collecting, you can go to this link, which is also here, and then you can read all about it. So what are we actually using? So we have three categories. Telemetry, which is essentially the hardware specifications, what the user is doing in the app, and a few other bits and pieces. We also have the metadata, that's the image dimensions, acquisition parameters for the image that you have, and hardware used to create that image. And then in some specific cases, and for now we're only doing that with internal users and with internal data only, we can collect also or use the image data, the actual raw image data, but only for internal, meaning people from within Leica using Leica data. And then what we do is train a model that is going to learn the relationship between the raw data and the ground truth, and then predict what the image analysis parameters should be given any other new raw data set. So in a little bit more detail, we start with the raw data, which includes the telemetry and everything else I mentioned. We also have the 3D image data for the model that we are currently releasing, which means we have used a number of data sets that are Leica created and Leica owned. From there, we did some curation on this telemetry to make sure to take away the noise and prepare the data to be used for training. We then, down here, we convert these 3D image data sets, which can be very large, into 2D tiles of the areas where there is actual signal and there is anything of interest. So it looks a little bit like this. We then feed these tiles through VGG16. This is a model published in 2015, has been trained with millions of data sets and is very good for image classification. We use that to create a feature map, essentially a representation or a simplified representation of these tiles goes into this feature map. And then we use that feature map together with the parameters that were used by expert users in Aivia, and we train a multi-head model to predict multiple parameters. And then we have predictions. So this piece is a model or an ensemble of models that we pre-train and we ship with Aivia.tiff. So when you press that button that I mentioned in the previous slide, that I said triggers the Aivia.learns, that's what's happening, is applying the model that was trained using this approach that I have here. So these predictions will be fed into all of these areas where I have the arrows. So it will feed all of these numbers, and also whether or not we do background subtraction, whether or not we do object separation, all of that is predicted by this AI model. So all of this is shipped in Aivia 10, and from your point of view, all you need to do is press that button at the top, and it triggers it. It's also possible to press this button right here, which is grayed out in this case, but if you press that button, it also predicts the parameters. So what does that look like in action? Here we go. So here we see a image. The image is loaded. Go to the very top. You can press there. And you can also, as I said, press inside the recipe console. You ask to predict. Aivia will estimate the analysis parameters. It feeds all of them into the recipe directly. And then all you have to do is press start. The image will then be processed. You can do the whole image, or you can do an ROI if you prefer to do it faster, just to check if it's good enough. And that's, in a nutshell, it. We have done this on a number of datasets. I can share with you a sample of datasets we tried. So this is the raw dataset at the top, a human expert doing the analysis, and then our autonomous image analysis being deployed. And you can see that in many cases it's pretty good, almost as good as the human expert. In some cases, not discernible difference. In other cases, we are a little bit over segmenting, so creating objects that are bigger than the objects that the expert user would have created. In other cases, we are over partitioning. You can see here, this is a little bit over partitioned in comparison to the human expert. But pretty close. In other cases, again, this is similar to that one. It's a little bit over segmenting, so this is a little bit lower threshold probably. So it created slightly bigger objects, but it gets in the ballpark very quickly, and so on and so forth. So you can see generally you should get a good enough preview, and in some cases a really good analysis straight away out of the box. So the next part of the presentation will focus on Aivia.tiff. We have been working on the Aivia.tiff file format during the last more than a year, actually, and we are introducing a few more benefits related to that work. We have now much faster image conversion, so it's 45% faster than with Aivia 9.8.1. We've also introduced a more efficient compression algorithm, and it's lossless compression, but the files on disk actually can be up to 35% smaller than with 9.8.1 or any other previous version. And all of this with no additional cost to you. As a user, the image rendering and the image processing has stayed identical to what it was before. And that's, of course, a balancing act here. We could have done, the compression could have been a lot more aggressive. So we could have reached a bigger number here or a bigger number here, but then it would come at a cost of slowing down the volume rendering or the image processing. So we didn't want to affect that part, but wanted to improve the others, and that's what we've done with Aivia 10. We also created a lot of documentation and provided examples of how to create and read Aivia.tiff files. These are open access in our GitHub repository. You can go there now and explore them. All of these wonderful and exciting features that I just talked about have been, of course, developed by a large team, very collaborative, and really a pleasure to work with. Here's the Aivia team. You already know many of them. There's a few new faces that you may recognize, but I wanted to thank and congratulate everybody for their great effort, especially on the file format, file viewer, and rendering of TauSense data. Chris, primarily, and also Casey for the implementation of the library viewer there. Then for the active tiles, Casey was the main person working on that together with Hoyen. Then the Aivia that learns, really a lot of people collaborated to make that happen. On the image analysis and ground truth creation, most of the customer-facing team, product specialists, as well as product management team, marketing, all collaborated to create that ground truth. Then Hideki and Hanyu and Chi on training the deep learning models that make it all possible. And then pretty much the whole software team got involved in creating the software interactivity and the experience that you now see in Aivia 10. Before I go on, I wanted to explain a little bit this picture on the left-hand side. This is from a celebration of becoming part of Leica Microsystems. These are the letters that used to be behind me in the studio where we recorded all the webinars. These have now been distributed to different people that have had a key contribution to the history of DR Vision and now Aivia, of course. And so these are the people that hold it. The only person that you may not recognize is this gentleman here. This is actually my son. He's holding the N letter in place of Quinn because she couldn't make it to that celebration. I would also like to thank everybody that we've interacted with and worked with at Leica, our broader team now. We have been made to feel very welcome at Leica Microsystems. Really exciting period for Aivia and for me particularly as well. I've been interacting heavily with a lot of these people mentioned on the list, and they've really helped us a lot integrate into the wider Leica team. Of course, I cannot mention everybody by name, so I'd like to thank in general the whole LSR business unit, as well as the Wetzlar and Mannheim R&D teams. They have been helping us and guiding us along the way, and the broader LMS team, including the legal team and the HR and everybody else that helps us every day get our job done. So, Aivia 10 in a nutshell. We have made it a lot easier to enjoy your Leica Microsystems datasets. You can use TauSense data, you can open multiple Leica file formats. I think it should be a lot easier to do now. We've also lowered the barrier to enter into Aivia, and hopefully you will feel that the next time you try Aivia or try to explain Aivia to somebody. It should be a lot easier, a lot faster to get to some results. We started to introduce to you our concept for fully autonomous image analysis powered by a variety of algorithms, including deep learning. And of course, it's equally powered by data that you can also contribute, telemetry data, usage data that you can contribute, which will help Aivia become smarter and better at segmenting images for you. Also the increased reproducibility and openness of the Aivia.tiff. In fact, this is something I should have mentioned in the previous slide. This is something that primarily Chris was working on over the last year. So great work there as well to make the Aivia.tiff faster as well as smaller. So before I wrap up for today, I wanted to encourage you to upgrade. If you're already an Aivia user, you can upgrade to Aivia 10 right now. If you're not an Aivia user and want to try it out, you should reach out to your local Leica account manager or your Aivia team representative, and they will be happy to point you in the right direction. You can also go on the Aivia website and request a trial license right now. If you haven't tried Aivia Community, this is a freeware that you can use forever. Good for rendering and exploring datasets, includes a lot of the good stuff that Aivia offers. And keep an eye out on our events and news. The next one, big one for Aivia, is going to be the AI Microscopy Symposium, which should be early September. But there's a lot more events going on within Leica, and you should check out the events coming up in your region or the global events. With that, I want to thank you for participating. I have time for a few questions, so I'll stay here and answer any questions that might have been written on the chat or that might come up now. So thank you so much. Thank you for your interest in Aivia and Aivia 10. And it's been my pleasure to introduce Aivia to you today.